Jared is coughing. The speed in meter per second given by VR with which he expels air depends on the radius r of his windpipe, given that r is between 0 and 9 in millimeter. By this formula v of r, and we are asked what values of r maximize the speed, for what values is the speed is minimized. Here, this question is asked us to find a global maximum and minimum of the function v of r. Notice here the interval of r is it's a closed interval between 0 and 9. That means we're gonna follow the steps of a closed interval to find global maximum and minimum. This is gonna be first finding the critical point, and then 2 evaluate critical point and endpoint in the function v of r, and then 3 find the highest value, which is global maximum, and lowest value, which is a global minimum. So first, let's find the critical point. It's where the first derivative is 0 or undefined. To take the derivative of the function, we have to use the product rule, since this is two multiplied functions. So I'm gonna assign f to 9 minus r and then g to r squared. Now I'm gonna take the derivative of each. And now we are ready to apply the product rule. So v of r gonna be, don't forget the point 1 first, and then gonna be the product rule. So minus 1 multiplied by r squared and plus 9 minus r multiplied by 2r. Now we can simplify this term, so it's gonna be minus r squared. Then I'm gonna distribute 2r to inside the parentheses. It's gonna to be 2 plus 18r and then minus 2r squared. Notice here r squared is a similar term, so I'm gonna subtract these. It's gonna be minus 3r squared plus 18r. Now I'm gonna also factor similar terms in here. We have minus 3 and r, and then gonna be r minus 6. Now that's gonna be minus 0.03r multiplied by r minus 6. That's the first derivative. Now where's this undefined? Notice this is defined every values of r. That's including our interval, which is between 0 and 9. Now where the first derivative is 0, gonna be 0 when the first term is 0, and that's gonna result in r equal to 0, and the second term is 0, and that's gonna be when r is 6. Now notice that r 0 and 6, it's in our interval, what is between 0 and 9. Now for step number 2, I'm gonna evaluate our critical point 0 and 6 and our endpoint, which is also 0 and then 9. Now we have all the values of the evaluation. Note that the maximum value is 10.8 meter per second and the minimum value is 0. Therefore, at r equal to 6, we have a global maximum. So to maximize the speed, r has to be 6. And then at r equal to 0, as well as r equal to 9, both of them will result in 0, and that's a global minimum. The speed is minimized